Hello, my dear students. Welcome to IKSR chemistry classes. Here we are in lecture number 4 on symmetry and group theory. In this video, we will discuss inversion operation and center of symmetry. Inversion operation and center of symmetry. If the reflection of all the atoms of a molecule if the reflection of all the atoms of a molecule through a point within the molecule produces an orientation which is indistinguishable from the initial one, it is called inversion operation, and that point is called center of symmetry or point of symmetry. It is quite easier, and let us understand it again. If the reflection of all the atoms of a molecule through a point within the molecule produces an orientation which is equivalent, which is indistinguishable from the initial one, it is called inversion operation, and that point through which reflection has been carried out is called center of symmetry, and its another name is also point of symmetry. Center of symmetry can be understood in more simple words also as follows. If any line passing through a point within the molecule, if any line passing through a point within the molecule meets identical atoms on both the sides at equal distances, that point is called center of symmetry and it is denoted by I. If any line passing through a point within the molecule meets identical atoms on both the sides at equal distances, that point is called center of symmetry. Let us exemplify it taking example of Pcl5 molecule. This molecule has a square planar shape. This line passing through xenon atom meets identical atoms on two sides at equal distances. Here fluorine atom is present and on the opposite side at the same distance another fluorine atom is present. These two atoms are identical. Similarly, this line which also passes through xenon atom meets identical atoms on both the sides at equal distances, and therefore xenon atom of Pcl5 molecule is center of symmetry, that is I. Center of symmetry may be present in molecules having linear, square planar and octahedral shapes. Center of symmetry may be present in molecules, not necessarily present, may be present in molecules having linear, square planar and octahedral shapes as illustrated below. CO2 molecule has linear shape. This line passing through carbon atom meets identical atoms on both the sides at equal distances, and hence carbon atom of CO2 molecule is center of symmetry. Here I is present, center of symmetry is present. Pcl5 molecule, we have already seen that xenon atom of Pcl5 molecule is center of symmetry. This molecule has a square planar shape. And SF6, this molecule has octahedral shape. This line passing through sulfur atom meets identical atoms on both the sides at equal distances. This line also meets identical atoms on both the sides at equal distances, and this line passing through sulfur atom meets identical atoms on both the sides at equal distances, and therefore sulfur atom of SF6 molecule is nothing but center of symmetry. Center of symmetry may be present in molecules having linear, square planar and octahedral shapes. The molecules having center of symmetry are called centrosymmetric molecules. The molecules having center of symmetry are called centrosymmetric molecules. Center of symmetry is absent in most of the other geometries. Center of symmetry may be present in molecules having linear, square planar and octahedral shapes, but center of symmetry is generally absent in most of the molecules having other geometries. Here H2O molecule is given which has bend shape. This line passing through oxygen atom does not meet identical atoms on both the sides at equal distances. Here hydrogen atom is present, but no hydrogen atom is present on the opposite side, and hence center of symmetry is absent in H2O molecule. This line also does not meet identical atoms on both the sides at equal distances. Here hydrogen atom is present, but hydrogen atom is not present on the opposite side. Bcl3 molecule has triangular planar shape. This line passing through boron atom does not meet identical atoms on both the sides at equal distances. Here chlorine atom is present, but no chlorine atom is present on the opposite side, and hence I is absent in Bcl3 molecule. CH4 molecule, it is a well-known tetrahedral molecule. This line passing through carbon atom meets hydrogen atom on one side, but no hydrogen atom is present on the opposite side, and therefore CH4 molecule contains no center of symmetry, and thus center of symmetry is absent in this molecule. And now Pcl5 molecule, which has triangular bipyramidal geometry, trigonal bipyramidal. This line passing through phosphorus atom does not meet identical atoms on both the sides at equal distances. Here chlorine atom is present, but no chlorine atom is present on the opposite side, and hence Pcl5 molecule having trigonal bipyramidal geometry does not contain center of symmetry. I is absent in this molecule. The molecules having no center of symmetry are called non-centrosymmetric molecules, while the molecules having center of symmetry are called centrosymmetric molecules. Both inversion operation and center of symmetry are denoted by the symbol I. Both inversion operation and center of symmetry, that is point of symmetry, are denoted by a common symbol I. During inversion operation, it is most important. During inversion operation, each atom of the molecule is moved towards the center of symmetry. During inversion operation, each atom of the molecule is moved towards the center of symmetry and then to the opposite side by the same distance. It is quite easier. During inversion operation, each atom of the molecule is moved towards the center of symmetry and then to the opposite side by the same distance. Inversion operation in CO2 molecule. It is CO2 molecule whose carbon atom is center of symmetry. Because this line passing through carbon atom meets identical atoms on both the sides at equal distances. Let CO2 molecule be reflected through carbon atom. Let CO2 molecule be reflected through carbon atom. During inversion operation, this oxygen atom, blue colored oxygen atom, is moved towards the center of symmetry, carbon atom, and then to the opposite side by the same distance. It means this oxygen atom will come to this position. This blue colored oxygen atom will come to this position. That is, its image will be formed here. Blue colored oxygen atom comes to this position. This atom is moved to center of symmetry and then to the opposite side by the same distance. Blue colored oxygen atom will come here, while the image of red colored oxygen atom is formed here. It can be understood in another way also. This red colored oxygen atom is moved towards the center of symmetry and then to the opposite side by the same distance, and hence this red colored oxygen atom will come here. Now orientation number 1 and orientation number 2 are equivalent, not identical, are equivalent or indistinguishable, and hence the reflection of CO2 molecule through carbon atom is inversion operation, and carbon atom of CO2 molecule is center of symmetry. Absence of center of symmetry in Bcl3 molecule. We have already seen it, but let us prove it again. It is Bcl3 molecule. It is its orientation number 1. Bcl3 molecule is reflected through boron atom. This blue colored oxygen atom is moved towards boron atom and then to the opposite side by the same distance. Therefore, this blue colored chlorine atom will come to this position, and its image will be formed here. If reflection is carried out through boron atom, red colored Cl double dash atom will come to this position and its image is formed here. Pink colored Cl dash atom. In this reflection operation, this pink colored Cl dash atom is moved towards boron atom and then to the opposite side by the same distance, and it will come to this position. Now see, orientation 1 and 2 are equivalent or not? Certainly, these are not equivalent. Here chlorine atom is present, but no chlorine atom is present at this position, and therefore orientations 1 and 2 are different. Therefore, the boron atom of Bcl3 molecule through which reflection has been carried out is not center of symmetry. and the above action, this action, reflection through boron atom, is not a symmetry operation. Please recall that any action which leaves a molecule looking the same is called a symmetry operation. But this action, reflection of Bcl3 molecule through boron atom, does not leave the molecule looking the same. These two are different orientations, and therefore the reflection of boron atom, reflection of Bcl3 molecule through boron atom is not a symmetry operation. Inversion operation on XeF4 molecule. Let us consider XeF4 molecule in which xenon atom can be regarded as center of symmetry. We have already seen it. A square planar shape this molecule has. It is orientation number 1, and this molecule is reflected through xenon atom. Its image will be formed here, and its image will be formed here. The new orientation obtained is 2. F triple dash will come to this position and F dash will come to this position. Its image will be formed here, F, and its image will be formed here. Orientations 1 and 2 are indistinguishable or equivalent, and therefore reflection of XeF4 molecule through xenon atom is an inversion operation, and xenon atom is center of symmetry. Let us apply inversion operation or orientation 2 again. As a result, its image will be formed here, and its image will be formed here. This F double dash atom is moved towards center of symmetry, and then to the opposite side by the same distance, F double dash atom will come here, and this red colored fluorine atom will come here. Now let us compare orientations 2 and 3. These are again equivalent or indistinguishable orientations, and hence it is inversion operation. On moving from orientation 1 to orientation 3, inversion operation has been applied 2 times. Inversion operation is applied here and again it is applied. Now compare orientations 1 and 3. This blue colored F dash atom is present here. In this orientation also it is present here. This red colored fluorine atom is present here. This red colored fluorine atom is present here also. And therefore orientations 1 and 3 are identical. It means if inversion operation is applied twice, the overall result is identity operation. The symmetry operation that produces an identical orientation to the initial one is called identity operation. It means I multiplied by I, that is I square, is equal to identity operation. Number of symmetry operations about center of symmetry. There may be only one center of symmetry in a molecule. In a molecule, there may be maximum one center of symmetry, about which only one symmetry operation can be carried out or applied. Please note it again that any molecule can have one or more axis of symmetry, plane of symmetry, but any molecule can have maximum one center of symmetry, about which only one symmetry operation can be applied. Let us illustrate it. We have already seen that I square is equal to identity operation. I to the power 3 will be equal to I square into I. I square is equal to E. We have already seen E into I will be equal to I. I to the power 4 is equal to I square into I square, that is E into E, and E into E will be equal to identity operation. In general, we can say that I to the power n is equal to E when n is even, such as I square is equal to E, I to the power 4 is equal to E, and I to the power n equals to I if n is odd, such as I to the power 3 is equal to I. Thus we can say that only one symmetry operation, that is I, can be applied about center of symmetry, because I to the power n is equal to identity operation when n is even, and I to the power n equals to I if n is odd. Now the time for self-assessment. Classify the following molecules into centrosymmetric and non-centrosymmetric categories. COS carbonyl sulfide, NH3, Bcl3, H2, HCl, XCF2, OF2, C6H6, C2H2, C2H4, C2H6 having eclipsed conformation, and C2H6 having a staggered conformation. At the same time, state the position of center of symmetry in the molecule if the center of symmetry is present, such as in CO2 molecule, carbon atom is the center of symmetry. You have to mention the position of center of symmetry in these molecules if it is present. Thank you for watching the video with concentration.